Okay, so for part B, it says the region R is a base of a solid where y, for each y, where y is from 0 to 2, the cross-section of the solid taken perpendicular to y-axis. So that means that the cross-sectional area is going to be this length here. Okay, so it's going to be that length there. So where the cross-sectional area perpendicular to the y-axis is a rectangle whose base lies in R and whose height is 2y. So this is going to be the base. We're going to have a rectangle go up like that, and that's going to be twice the y position. So if it's at 1 here, it'll be 2 high. Okay, so those are going to be the pieces, and we're going to integrate along dy. So for part B, okay, we need to express this y value, the x position in terms of y, because we want to get this horizontal length. Okay, so we're going to use the x positioning. So if f of x is root x, y equals root x, okay, x is equal to root or y squared. Okay, for the other one, if y is equal to g is equal to 6 minus x, okay, x is equal to 6 minus y. Okay, so that represents g, and we want the g minus, so this would be, I'm just going to put in here, this is our g, this is our f. To get the horizontal positioning, we want, I'll call h, is going to be g minus f, which is equal to 6 minus y squared. Okay, so that's my horizontal position. That's going to be that horizontal line here. And to get the area, we're going to multiply it by 2y. So then the integral that we want to solve, it says write but do not solve. So the integral is going to be the area, which is the height. It's going to be 6 minus, the width, 6 minus y squared times the height, which is, we told that's 2y. We're going to take slices along dy, and we're going to integrate from 0 to 2. And that would end up being our volume expression. Okay, so there it is. That's for that volume, that's the integral that we would use. Now, this is fairly easy to integrate if we want to. Okay, so for part C, okay, it says that for part C, it says P is a point on the graph of F, which the tangent line to the graph is perpendicular to the graph of G. Okay, so there's our, if I just extend that line, we want a tangent line which is going to be at 90 degrees. Okay, so what that means is that, well, that G function is a fixed slope of -1. Okay, so we want to know where the tangent line, or the f prime, is equal to the perpendicular, which is +1. Okay, so that's going to be 90 degrees to the slope of G. Okay, so if I want to figure that out, I want to know the position of that. I need to first of all find the derivative. So the derivative of square root x is 1 over 2 root x, and I want to know where that's equal to 1. Solving for x, I end up with 1/2 equals root x, x equals 1/4. I plug that back into my my f equation. If x is equal to 1/4, y is going to be equal to, I'm just going to plug it in there, y would be equal to 1/2. So then there's my coordinate. Okay, so P has a point at x is 1/4, y is 1/2.